Alright guys, welcome back to the channel. Previous video, we got it just working. By working, I mean we relied on a lot of defaults from AWS. In this video, we're going to actually create microservices on AWS ECS in a production ready sense. We're not going to rely on the default VPC, the default security group. We're not going to enable public IPs for our ECS services. Instead, we're going to have them in private subnets, which is the production ready way to do this. So in this video, we're actually going to create all of the components I mentioned in the intro video. Remember that big slide with a bunch of different AWS components where I said don't get overwhelmed. I know this looks daunting, but we're going to walk through. It's actually pretty easy how they all fit together. We're going to see that all right now in this video. And I'll reiterate again, yes, there's a lot of components, but no, it's not going to be overwhelming. We're going to go through each one in great detail and explain how each one pieces together to create what we need at the very end. So trust me when I say this video will not be overwhelming. If you follow along, you will understand everything by the end. All right, so step one, obviously, if you haven't followed along in the previous videos, is get the code. Here's the URL. It says on GitHub. I'm going to put the link to it in the description below. I'll also put it on the screen. It's private right now, but it's going to be public by the time this video goes live. And we're going to see how we can upload this code to AWS and get microservices working. Before we get started, though, help me out a lot by liking this video, commenting below, and subscribing to the channel. Helps me out a lot. And if you want to do the extra mile, you can sponsor me on GitHub Sponsors. You can either do a recurring or one time, or Patreon, which is only recurring. I'd appreciate anything. It helps me out a lot. Helps me afford new equipment like this microphone I'm using to make the videos not sound as choppy or as staticky, which I'm sure everyone appreciates as watching. So yeah, with that being said, let's get going. So step one is just going to be to clone the repo. Just going to go to code right here, copy to the clipboard, open your terminal, and just do git clone, paste the repo. Once you have it cloned, you can open up in your favorite code editor. I'm going to use Visual Studio Code. Here we go. And we kind of look at the code a little bit. This is kind of a rehash from the last video, so feel free to skip ahead if you watched that one already. But what we have, going back to the code right here, is we have three apps. Flask app 1, 2, 3. Each one's going to be a separate microservice on AWS. So we're going to push each one of these to separate ECS services, where each ECS service represents a separate microservice. Flask app 1 and 2 are going to be in the same ECS cluster. Flask app 3 is going to be its own ECS cluster. And they're all going to use the same Docker file. So go into the code. Here's Flask app 1. We have datetime, simple requests, making rep requests. This is how we're going to talk between the microservices. From this init function, we're importing the create app function. This is just creating the Flask app, .env to load some environment variables. This is only really for locally. And then we create the app by calling the create app function. Then we have a few routes. Here's where we're starting to get into a little bit of the stuff that actually matters. Default route, this is just to let us know that, yes, we're able to connect to Flask app 1. And here's where we actually implement microservices. Get message, we're running this to actually connect to the Flask app 2. And we're calling this environment variable port Flask app 2, which we're going to define in the ECS task definition. And we do the same thing here for port Flask app 3, which I'm going to be calling Flask app 3 microservice. And this is the one that's going to be in a separate cluster. That's why we just denote the URL as get messages across cluster. We could have called it whatever we wanted. I'm trying to be very descriptive here to make it easier to follow along in this video series. And then we see in Flask app 2, and likewise in Flask app 3, it's going to have just a simple function called return message. We're not going to worry about connection between Flask app 2 and 3 or Flask app 2 making request to Flask app 1. It's only going to be Flask app 1 requesting to Flask app 2 and 3. Flask app 1 is going to be the entry point of our application, meaning clients can talk to Flask app 1, and Flask app 2 and 3 are just going to be backend microservices. Obviously, you can expand on this if you want and make them all talk to each other, but for this simplified example, we're just going to have Flask app 1 making requests to Flask app 2 and 3. All right, now that we see the code a little bit, just a quick rehash from the last few videos, let's actually get it running on AWS. Now, the big difference between this video and the last video is in the last video, we didn't do any kind of networking setup. We relied on everything by default, and we put things in public subnets that shouldn't be in public subnets because it exposes it to the outside world and makes it more vulnerable. Instead, we're going to have everything be restricted. So the way we're going to do this is first we need to create what's called a VPC. If you've done anything with AWS, you probably know EC2, you might know Lambda, and you probably know VPC. VPC just stands for Virtual Private Cloud. is a segmentation of your network on AWS for specific applications. So that network cannot be penetrated by any outside sources unless you specifically allow them to. So with our VPCs, we're going to click in, and we're just going to create a VPC. What are we going to call it? Let's try to be consistent here. Can make it easier to follow along. So what I want you to open up is the AWS ECS deploy.yaml in the .github workflows folder. Again, from the last video, we were very consistent with our naming convention. We're going to do the same thing here. We're going to copy this prefix here, which you use throughout the definitions here. And we're going to go here, do the same thing, and just do -VPC. You can call it whatever you want. This is just pure choice on my part, but I'm trying to make everything very consistent, make it easier to follow along. So for the CIDR, we're just going to use what they suggest, /24. Scroll down, and we'll create the VPC. Great, we got a VPC. We can go back, and we see it right here. Next, we want to create the subnets. So with the subnets, we're going to have private subnets and public subnets. We're going to put the ECS services in the private subnets. What this does is prevents any unsolicited incoming traffic coming into our ECS services because they're in a private subnet. They're not publicly exposed on the internet. Where in the previous video, we had to give a public IP to each one of our ECS services to allow them to pull from the Elastic Container Repository ECR image. This is bad. It's not what you should do in production, which obviously we're going to fix here. And we do that by creating these VPC, these subnets, NAT gateway, internet gateway, etc., which we're going to see as we go along. So let's keep going. The first thing we want to do, create subnet, VPC, the one we just created. And here's our CIDR, right? So what's a good name for this subnet? Well, let's go down here. Let's keep the prefix going. Go up, and let's call it private-1. Availability zone, just do US East 1A. This is not something you have to do. This is purely just preference. Now for the subnet, I'm also going to use the suggested value as well. 10.0.0/28. This gives me 16 IPs as indicated right here. You can give yourself more if you want. I'm just following along what they suggest. Keep going. Got another subnet. We're going to copy the name up here. Now for this example, we're only going to have one private subnet. Because we really only need one. We're going to have two public subnets. Why is that? Because we're going to attach an application load balancer as the entry point and a record for our application. And with an application load balancer, you must have at least two public subnets in different availability zones. So that's where we're going to create two public subnets here. Go back, just change this to public 1. Availability zone, we'll do 1A for the first one and 1B for the second one. All you need to make sure is that you have a different availability zone for the first public one and the second public one. Same CIDR block, and then for the subnet, we're just going to do a different one. 10.0.0.0/16/28. This is just the next group of 16 IPs. And we're going to copy the name, scroll down, add one more, public 2, availability zone, make sure it's different than the first public subnet. We're just going to do 1B, and then 10.0.0.032/16. This is just the next group of 16 IPs. So then we're going to create the subnets. And boom, we got the 3 subnets. Real quick, go back to the VPC, click into it, resource map, and we can see here's our 3. We also see they're routing to a route table right now. We're going to change this because now all of them are routing to the same route table, which is not what we want. We want separate route tables for the public and the private subnets. This is how we denote what a public and a private subnet are. So next, we can actually go and create our NAT gateway. This is going to sit in the public subnet and allow our ECS services in our private subnets to talk to the internet. So let's create our NAT gateway. Same prefix, just keep everything consistent. Again, you can do whatever you want. And let's call it -NAT. Select the subnet. It's going to be in the public subnet. So let's put in public 1. Connectivity type, we're going to set it as public because we do want public access to the outside internet inside of our application. It's not going to be an isolated internal application. And we must assign an Elastic IP, which is also required for the NAT gateway to allow the ECS services in the private subnets to talk to the internet. All right, we can create it right now. That's pending. Next, we can create our internet gateway. Create internet gateway. Same thing, same prefix. Right here. Paste. IGW for internet gateway. Scroll down, create. We're going to do actions, attach to a VPC, and the one we just created. Attach. Boom. Let's double check our NAT gateway, make sure it's created. We're just going to wait a little bit for this to finish creating. All right, once the NAT gateway is created, click into it, just take a few details. You see it's available. Here's our IP address that was assigned, the Elastic IP. And then what we can do is go into the route tables, refresh, and we'll see that we have one created for the specific NAT gateway. Because whenever you create a NAT gateway, a route table is automatically created for it. And we see it's this one right here, as indicated by the VPC we created. So we're going to click into here. We're going to do our routes, and we're going to edit our routes. Add route 0.0, connect to the, no, select the internet gateway right here. Now, what is going on right here? This is the main route table. This is the route table we're going to associate with our public subnets. In our public subnets, we want to route the internet traffic to the internet gateway because the NAT gateway is going to sit in the public subnets. The NAT gateway needs to route traffic to the internet gateway so it can go out to the internet. This is just the default internal local, but everything else we want to route to the internet gateway. So click Save Changes. All right, that's set. And then we can do next is subnet associations, edit subnet associations. We want to associate with this are the public subnets. Save associations. Great. Now, what we also want to create is go back and create a new route table for the private subnet. But before we do that, let's just quickly rename this just so it's easier to identify it later. To route table public, save, and we'll create a new route table. Route table private VPC, one we just created, create route table, and then we'll do the edit routes, add route 0.0, and this time we'll direct traffic to the NAT gateway. Why? Because this is going to be our private subnets. The private subnets are going to have our ECS services. As a reminder, I keep reiterating this. It's easy to get lost here, so I'm trying to repeat myself a lot. I apologize if some people more advanced are watching this video and find it kind of annoying, but for those that are really trying to learn, I'm trying to be very descriptive and very repetitive to make sure you really understand what's going on. So NAT gateway, save changes, and then our subnet associations, edit, and we're just going to do our private right here, save associations. Great, so we have our two route tables, and we go back to our VPC, do our resource map. Here we go. Public 1, public 2, both go to this route table right here. In this route table, the public one routes to the internet gateway. In our one private subnet, private route table routes to the NAT gateway. This is the easiest way to visualize how all these components connect. So I really recommend going to the VPC section on the side, clicking it, and going to resource map. It's very helpful to see this. It's actually somewhat of a newer feature, which I find very helpful personally. Okay, so that's the networking. Pretty straightforward to set up. May have been a little daunting if you haven't done it before, but step through each step 1 or 2 times more. Do it from scratch again. Watch this section of the video again, and I promise you, you will understand it. Okay, now that we're done with the networking setup, we can move on to actually creating the microservices like we did in the previous video. Only this time, we have the production-ready networking setup done. So when we create these microservices, we'll do them in the correct production-ready manner. We had something that worked in the last video, but in this video, we're going to have something that you can actually deploy to production, or that at the very least is much, much closer to production ready. Okay, so almost picking off where we started in the last video, we're going to start with Elastic Container Registry. Go and open up that in a new tab. And the first thing we need to do is create a repository. What is ECR? Quick reminder is we're going to store the repository for our Docker image. Again, we're using one Docker image shared between each one of the microservices. And we're able to do that by specifying the environment variable Flask app, pointing to each one of the separate microservices app.py, telling it where to run. Okay, so let's get the name. To do that, we're going to go to the code, .github workflows, AWS ECS deploy.yaml file, same as the last video. and we're going to copy the names just as we did in the last video as well. Again, these naming conventions are going to come into play later on in the video series, so I highly recommend you stick to what I'm doing here with these namings. Okay, go ahead and paste, scroll down, nothing else to do, create. Great, now let's push our Docker image. So view push commands. Now make sure you first have the AWS CLI installed and Docker Desktop installed. You also need to make sure Docker Desktop is currently running. The CLI is to log in and push the images. Docker Desktop is needed to actually build the images on your desktop. So once you have that, and we're just going to copy and paste commands. So right here, paste, login succeeded. We're going to build the Docker image. We're going to tag it. And finally, we're going to push it. Pushing might take a minute, so I'm going to go ahead and fast forward after that's done. Okay, once it's done pushing, we can close this, refresh, and then we'll see the latest image right here. Great. Next step is to go to Elastic Container Service. First thing we're going to do is create the task definitions, just like we did in the previous video series. Remember, we start the cluster, which has services, which you attach task definitions to. We're going to start at the bottom with task definitions, then we're going to create the clusters, then we're going to create the services within the clusters and attach the task definitions that we previously created to the services. So let's create a new task definition. The name, same file, ECS deploy.yaml. Here's the task definition name right here. Copy, paste, Fargate right here. It's sufficient enough to rely on the default task execution role. If you want to customize this more, you can, but this is one thing I'm going to leave as default. Container details, the name. Again, we're going to pull this from AWS ECS deploy.yaml right here. Go ahead and paste. The URI, we need the Elastic Container Registry. Click into it. Latest, copy the URI. Paste. Essential container, again, I mentioned this in the previous video, but because we only have one container, you have the option to run multiple containers if you want. So we can minimize this, we can add a container. But for this video series, we're only going to have one container per task definition. Essential container essentially means that if this container dies, then the whole task definition should die as well. Since there's only one, we're going to leave this as yes, because it just makes sense. Okay, port mappings, 5000 for Flask App 1. Port name, do the same as we call the name up here for the container, just keep consistency. And then we're going to do environment variables. Again, we need 3 of them, just like before. So let's go here. Go to docker compose.yaml, scroll up, and we're going to go to Flask App 1 right here at the top. This environment variable right here, paste, and the value is just going to be Flask App 1 app.py. Paste it right here. And then for Flask App 1 in particular, we need 2 additional ones. You scroll down to the get message route, you need the port Flask App 2, which is going to be 5001, and port Flask App 3, which is going to be 5002. The reason being is that Flask App 1 is the entry point to application. This is what the application load balancer is going to attach to, is ECS service 1, and it's going to make requests to ECS services 2 and 3. 2 and 3 are not going to make requests to Flask App 1, so you don't need to worry about any kind of configuration app mappings here for Flask App, port Flask App 2 and port Flask App 3. We only need it for Flask App 1. Okay, continuing on. And the only thing we need is Docker configuration. Go back, Docker compose. Right here, we have this command right here. Just do a new tab, Control V, and just remove the quotes. And there we go. Okay, that's all we need. So create. Then let's do the same thing for the other 2. So a little quicker. Here's the names, task definition, 2. You'll see I do just -2, -3 to make it easy. Same configurations, I'm not going to repeat too much here. Flask App 2, just pulling it from right here. URI, same URI, one Docker image for all 3. Such container, yes, just like before. Port is 5001. Port name, same as the container name, keep consistency. Environment variables, we only need one. Docker compose.yaml, scroll down to Flask app 2. Here's our one environment variable. Copy, paste, copy, paste. Copy, paste, prevent any manual transcription errors if there's going to be any. Scroll down. We just need the Docker configuration, the command. And we already have it here. We just have to change one value. Instead of 5,000, it's going to be 5,001. Great. That's all. And continuing on, one more, create new task definition. Go back to deploy.yaml, right here. Task definition 3. Paste. ECS task execution role. Great. Container name. Copy from right here. Flask app 3. URI. We're going to get it from right here. Great. Search container. Yes, just like before. Port 5002. Port name. Flask app 3. Be consistent with the container name, just like the other two. Environment variable. We only have one. Docker compose.yaml. Scroll down. Flask app. Right here. Scroll down. Flask app 3. app.py. Great. Scrolling down. What else do we need? Docker configuration. The same as the other ones. Just change the port from 5000 to 5002. Great. And create. Okay, click task definitions, minimize this. And we see that we have all three task definitions. Great, just like the previous video. Now let's go into clusters. Let's create our two clusters. We're going to go here. We're done with this file, so we can close it. Scroll up, and then cluster name 1 right here. Paste, namespace. We're going to create a single namespace that's going to be shared among both of the clusters, meaning all the services. This is what allows ECS Service Connect to work so they can all talk to each other as microservices. Fargate, just like the task definitions, and that's all. Create. Create another one. Go back. Different name. Paste here. Same namespace. Fargate, and create. Okay, I'm going to fast forward once both these clusters are done creating. Okay, cluster 1 and cluster 2 are done creating. Quick reminder, I've said this in every video, I'm going to keep saying it. Cluster 1, we're going to have ECS Service 1 and 2. Cluster 2 is going to have ECS Service 3. The reason I'm doing this is to demonstrate that ECS microservices with Service Connect can communicate with each other within the same cluster and across clusters. So I'm just demonstrating both functionalities with the two different clusters. Okay, and again, just like I said before, it's recommended to create ECS Service 2 and 3 before ECS Service 1. This establishes the network mesh and is recommended by both support, and I found this in my own experience by making this video series, that you have less chance to run into errors trying to access the different microservices if you create Service 2 and 3 first, rather than Service 1. So that's what we're going to do in this video. So let's go into cluster 1, and let's create ECS Service 2 first. Create, scroll down, Fargate, task definition. We're doing Service 2, we're going to do task definition 2 as well. Service name, let's copy it from right here. Copy paste, simple enough. Scroll down. Turn on Service Connect. This is what enables us to use microservices with ECS. This is the service provided by AWS, Service Connect. It's going to use that namespace that we created previously. Let's go to Cloud Map real fast and see it. This is the namespace that we created. We use the same namespace for each one of the services. And then when this is specified, we're going to be able to access them through that Cloud Map namespace. So that's why we select the namespace right here. And then we're going to add port mappings. Port alias, this is what we specified in the task definition. Discovery, we don't actually need to specify this. We only need to specify the DNS. And where do we get the DNS? Well, we go to Flask app 1 app.py and copy it directly as is from right here. If we don't copy it directly as is, we will get errors. So 5001. Scroll down. Now for the networking. This is where we hand wave things away last time, remember? We relied on the default VPC, as we see here. We relied on the default subnets, as we see here. We relied on the default security group, and the public IP was turned on, which was not recommended. Instead, since we did all the networking setup previously, we're going to use all those now. VPC, right here. That's our Service Connect demo VPC. For the subnets, we're only going to keep it in the private subnet. Why is this? Because for the ECS service, we're going to have an application load balancer as an entry point to our application. Meaning our ECS services don't need to be exposed to the public internet. The application load balancer is going to take in all incoming traffic. So there's no direct connection from the outside internet to our ECS instances, which is much more production ready. Security group, we're just going to use the default one for this specific VPC. Let's double check that real quick just so I can explain what I'm saying here. Let's go to the VPC tab. Our VPC is called Service Connect Demo VPC. So let's go to VPCs. And then on the left, let's scroll down. Let's open up security groups in a new tab. So we have two different security groups. One's for the original default VPC whenever you create a new AWS account, and the other one is for the one we just created. So let's go back and let's reference Demo VPC, ABC, ABC. So this is our security group we're referencing. This is the default one for the VPC we just created. Here's our inbound rules, allowing all traffic from within the security group itself. So we go back, we look at the security group, 9C1, 9C1. So even though this is the default security group, it's the default security group for the VPC we just created. So we are going to allow this, and we're not going to do anything with it. The public IP will turn off. But just going back to security real quick, one thing we will do though is we'll add the inbound rules, and we'll add a rule for custom TCP on port 80 to allow traffic from your IP. Now I put 0.0.0 here because I don't want to expose my own personal public IP. But what you would do instead, you would click my IP. The reason we're doing port 80 is because we're going to have the application load balancers I keep mentioning, and traffic's going to come in on that on port 80. Meaning that if you allow traffic on port 80, the application load balancer is going to be able to accept that traffic and forward it on to the ECS instance. So I'm doing port 80 here, I'm doing 0.0. You would do port 80 as well, but you would just do my IP. After you do that, you click Save Rules, and then we're done with this security group. Great. Now, in the previous video, we needed port 5000. That was because we were accessing Flask App 1 on ECS Service 1 directly by the public IP of Flask App 1. That's no longer going to be the case. It's private. It's not going to be able to be accessed through its own public IP because there won't be one. That's why we have to do the port 80 and your IP. Okay, that was a little bit of a detour. Let's keep going. No load balancing. That's only going to apply to Flask App 1 and ECS Service 1. Nothing else to do here. We're going to click Create. Great. Go back to the clusters. Go to now cluster 2. Scroll down. Create a service. Task definition. 3. Revision latest. Service name. Go back to ECS deploy.yaml. Copy. Paste. Great. Scroll down. We're going to use Service Connect. Again, this is what enables the ECS microservices. Select the namespace, same one for all of them. Port mappings, port alias, what we specified in the task definition. DNS. We're going to copy it directly from Flask App 1, app.py. Scroll down to the get message across cluster. Copy this DNS string right here. Paste. It's going to be port 5002 as we specified many times previously. Great. Scrolling down. Networking. Same thing here. We're going to use the Service Connect Demo VPC. For the subnets, we're only going to have it in the private subnet. So delete both of these public. Security group, we're going to use the default security group for the VPC we created. Again, 9C1. 9C1 refers to the VPC, ABC, which refers to the Service Connect Demo VPC. Apologies if I'm reiterating things a lot. Just want to make sure everyone understands and no one's getting lost. Public IP, we turn it off. Load balancing, again, no load balancing for service 2 or 3, only for service 1 because that's the entry point. Create. Great. Close both of these. Go back to the clusters. Then we see one task is running right here for cluster 1, and cluster 2 is spinning up the service now. So let's go into cluster 1 and let's create the service 1. So create. Okay, so let's go ahead and create it. Task definition 1, service name, right up here. Service 1, paste, scroll down, Service Connect. We only need client side because it's not being requested by service 2 or 3, it's only making the request. Scroll down, networking, Service Connect, Again, only in the private, no public. Security group, public IP is off. Now for the load balancing. Now we want an application load balancer, as I've said many times. Flask 1, 5000, that's good. We need to create a new load balancer. Now this is going to fail. Why? Because if we scroll up, we only have one private subnet attached. This, for an application load balancer, you need two public subnets. So what we actually have to do is we can't actually attach it here. What we need to do is create the application load balancer outside of here and then attach it down here after it's already created. So what we need to do is we need to go to here, VPCs. You can just open up a new tab with EC2. Scroll down, and we're going to go to load balancers. Create load balancer. Okay, we're going to want an application load balancer, create. Scroll down for the name. Let's copy the prefix right here. And let's do -ALB. It's going to be internet facing because we want public internet access to the ALB. IPv4. VPC, we want the Service Connect demo VPC. We need two availability zones. This is the reason that we created two public subnets when we were creating the VPC. We need at least two public subnets in two different availability zones. We're using US East 1A and US East 1B here to be able to create the application load balancer. So that's the reason we did that. Then the security group, APC, double check, APC. That's one attached to our subnet for Service Connect demo. Great. Scrolling down. We want to forward to a target group. We don't have one, so we have to create one. Now, because we're using Fargate, we're going to use IP addresses. It's going to be a random IP address for each new Fargate instance to get spun up. Target group name, we're going to copy the prefix. Do -TG for target group. Scroll down. Service Connect demo VPC. Great. Nothing else to do. And we're going to create target group. Great. Now we don't specify any registered targets because these are going to be created when we create the ECS service 1 and attach the load balance to it. It's going to automatically associate a target with it, which is exactly what we want. Because whenever we update the service, we want a new target attached to it automatically as well. Okay, so target group is created. We can close this, refresh right here. Here's the target group we just created. Great, that's our listener. And scroll down. Nothing else to do. Create load balancer. Load balancer is created. Awesome. Now we can go all the way back to right here. Now, unfortunately, we have to refresh and do this from scratch for ECS Service 1. No big deal. We barely did anything. So scroll to the top. Here we go. Service. Again, we're creating ECS Service 1. Revision latest. Service name. Go here. Copy the name. Paste right here. Scroll down. Service Connect. Yep. We only need client side. Namespace, same as the other two. Scrolling down. Networking. Same networking step as the other two. No public, only private. Same security group. Public IP is off. Now we're going to add load balancing. Again, we have to do this here because what this does, it means that whenever we update ECS Service 1, it's going to automatically update the target in the registered target group for the load balancer for us, meaning we don't have to do anything manually. Saves us a lot of time and headache. Use existing load balancer. Choose load balancer right here. Use an existing listener right here. Port 80. That's why we allow traffic on port 80 in our security group. And use an existing target group right there. Great. Everything's set up and click create. Okay, Service Connect 1 is being created right now. So go back to our clusters. Here's Service Connect 1. Scroll down, give it a refresh. The receipt is being created right now. Just got to give it a minute or so for that to finish creating. And once that's finished creating, we can go back to our load balancers right here. Let's go back to the top after it's finished provision. Right here, scroll down. Here's our DNS name. And what we're going to do, after we're finished creating ECS Service 1, we're going to be able to go here and actually see our ECS microservices in action. So let's go back to our clusters, give it a quick refresh again. We see it's in progress. Give it a little bit longer and it should be running. After that, we'll be able to access and actually see it in action. Okay, after a short while, you should see it running here as well. So we can go here. Here's the DNS name we copied. Go and click enter. And you see hello world from Flask 1. Great. Now let's test our two routes. Go back to app.py for Flask app 1. First route, get message. So we're just going to do /get message. Great, there's Flask app 2. Then let's test across the cluster as well. Copy, paste, and boom, message from Flask app 3. Great, so that's microservices on AWS using a production ready setup. We have the networking set up correctly with a NAT gateway, internet gateway, application load balancer, etc. We have the ECS instances in private subnets with an ALB in front of it, and we have all the proper naming conventions right now. So we can move on to the next video. We're going to do continuous deployment CD with GitHub Actions that allow us to automatically update our ECS services from GitHub Actions without having to do what we'd have to do manually instead. How we do this manually is we have to go to Elastic Container Registry, view push commands, build a new Docker image from the terminal. So have to build and push a new Docker image, then go over to our cluster, go over to our services right here, update service, and then force new deployment, and we select the new latest tag for the task definition. Now this is very clunky and very time consuming. And also, if you're using a production ready environment, you're most likely using version control with either GitHub, Bitbucket, something else. And with that comes a whole host of tools that you should be utilizing as well. That's why we're going to use GitHub Actions. I'm going to show you how powerful that is, where it's a simple one click. You push the code and then it will automatically deploy it for you, and you'll see those updates very quickly. So that's going to be the next video. I hope you learned a lot in this video though. Hope you have a good understanding of everything. If you have any questions, put them below. I'll respond as quickly as I can. If I can't, so I'm sure someone else will help you out as well. And yeah, thanks for watching and stay tuned for the next one.